In today's presentation, we'll be talking about the Floyd-Warshall algorithm. The Floyd-Warshall algorithm was created by two men, Robert M. Floyd and Stephen Warshall. The Floyd-Warshall algorithm was published by Robert Floyd and Stephen Warshall in 1962. This algorithm was essentially the same algorithm published by Bernard Roy 3 years earlier in 1959. The premise of this algorithm is as follows. This algorithm compares all possible paths through the graph between each pair of vertices. Next, every combination of edges is tested. And it does so by incrementally improving an estimate on the shortest path between two vertices until the estimate is optimal. This is the initial directed graph that we will be using. Here are the weights of the paths between each node. If a node is not connected to another node, the weight is set as INF infinity. We will now use the Floyd-Warshall algorithm to determine the shortest paths between two nodes. Dark red will be the main frozen rows and columns. Pink is the rows and columns connected to INFs. Blue is the current spot we'll be updating. First, we will freeze the first column and the first row. Next, we will freeze any row or column that has an INF on the main freeze. We will now be comparing 1 with 8 plus 7. Because 1 is less than 8 plus 7, which is 15, we do not change its number. Next, we will compare 6 with 1 plus 8. Because 6 is lesser than 9, we do not change its number. Here now is our updated graph. Because none of the numbers changed, our number graph has not changed. Just like with the first iteration, we will be freezing both rows and columns. This time, we freeze the second of each. We will be freezing any row and column that is connected to an INF in the main freeze. Compare the first INF with both 7 and 3. Because 7 plus 3 is less than infinity, this will have a new number in it. Now that we have updated the first INF, we will move to the second. Compare this to 3 and 1. 4 is less than infinity, so it will be changed. We now have an updated numbers table, so we will move to iteration 3. Freeze the third row and the third column. Once again, freeze any row or column that are corresponding to the main INFs. Compare INF to 9 and 10. Because this adds up to 19 and is less than infinity, it will now take the spot. Compare the second INF to 9 plus 3. Because 12 is lesser than infinity, it will now take over the spot. Last, we compare infinity with 9 plus 9. 18 is lesser than infinity, so it will now take over the spot. With those sorted, we now have our updated numbers chart. Freeze the fourth row and column. Now freeze any row and column that is connected to an INF on the main freeze. Because 10 is not in a row with an INF, it will be compared to 1 and 9. Because 10 is equal to 10, it will not be changed. Once again, because it is not in a row or column with an INF, 19 will be compared to 18 plus 1. Because 19 equals 19, it will not be changed. And finally, because 4 is not in a row or column with an INF, it will be compared to 6 plus 9. Because 4 is lesser than 15, it will not be changed. We are now at our fifth and final iteration of this graph. We will now freeze our final row and column of this table. There are no INF on the main freeze, so we do not have to worry about any other freezes. Compare 7 to 19 plus 1. It will not be changed. Compare 10 to 19 plus 4. It will not be changed. Compare 1 to 19 plus 6. It will not be changed. Compare infinity to 12 plus 8. It will be changed. Compare 3 to 12 plus 4. It will not be changed. Compare infinity to 12 plus 6. It will be changed. Compare infinity to 9 plus 8. It will be changed. Compare infinity to 9 plus 1. It will be changed. Comparing infinity to 9 plus 6. It will be changed. Compare infinity to 18 plus 8. It will be changed. Compare infinity to 18 plus 1. It will be changed. Finally, we will compare 9 to 18 plus 4. It will not be changed. We now have a table of the shortest paths using the Floyd-Warshall algorithm.